Hello viewers, welcome to my YouTube channel SCI-PHILE. In the series of videos on biomolecules, today I am going to start with one major class of biomolecules, that is carbohydrates. As you see that carbohydrates have an empirical formula of CmH2ON. This empirical formula gives an impression that carbohydrates are hydrates of carbon, and because of this attribute only they have been named carbohydrates. However, as you will see that this term is a misnomer because carbohydrates are not hydrates in the strict sense. As you know that hydrates are any compounds which have loosely attached water molecules which can be evaporated on heating. For example, you have copper sulfate pentahydrate CaSO4 5H2 or FeSO4 7H2. In both these compounds, for example, in copper sulfate 5H2 which is blue in hydrated form, once you heat it, it turns into anhydrous copper sulfate which is colorless and gives out water. The same you cannot do with carbohydrates. That means you cannot evaporate the water out, and for this reason carbohydrates are not hydrates. Students, now let us see the correct chemical definition of carbohydrates. As you can see, carbohydrates are basically polyhydroxy aldehydes and ketones. As the name suggests, they are supposed to have an aldehyde group in case of aldoses or a ketone group in case of ketoses, along with several alcohol groups. Several implies there should be two or more alcohol groups. So, conforming to this criteria, now let us see what can be the simplest examples of carbohydrates. As you can see here, in the category of aldoses, the simplest carbohydrate you can get should have one aldehyde group. As you can see here, this is an aldehyde group along with at least two OH groups. So, if you construct a molecule having one aldehyde group and two alcohol group, what you get is glyceraldehyde. This is D-glyceraldehyde. So, this molecule is considered the simplest aldose carbohydrate. Now, if we take a ketone group in place of aldehyde group along with at least two OH groups, then what we get is this compound, which as you can see it is dihydroxyacetone, that you might have read about in the chapter on ketones. So, as you can see, this compound is the simplest ketones that we can have. So, these two are the simplest examples of carbohydrates. Now, if you extend the definition to higher number of carbon atoms, here you can see two familiar examples of carbohydrates that every one of you should be familiar with. Here you see this is glucose. As you can see, it's a 6 carbon sugar and we number it like this: 1, this carbon 1, 2, 3, 4, 5 and 6. And this is as you can see, this is an aldose sugar because it is having an aldehyde group, and besides there are 1, 2, 3, 4, 5 OH groups. So, this compound is having one aldehyde group along with 5 OH groups, and this familiar compound is D-glucose. So, by definition it is polyhydroxy because it is having 5 hydroxyl group along with an aldehyde group. So, this is another example of polyhydroxy aldehyde in which there is one aldehyde group along with 5 hydroxy group. Similarly, here you see this is another famous molecule that you must be familiar with. This is D-fructose, in which you can see one ketone group. This is one ketone group along with 1, 2, 3, 4, 5 and 5 hydroxy group. So, by definition this is polyhydroxy ketone. So, this is a carbohydrate of ketose series. So, both glucose and fructose are carbohydrates. They are polyhydroxyaldehydes and ketones, while glucose is a polyhydroxyaldehyde, fructose is a polyhydroxy ketone. And one remarkable thing that you can observe here is that both are having same empirical formula. This is having C6H12 O6, and fructose is also having the same formula. Despite that, they are having different structures, whereas one is an aldose sugar, another is a ketose sugar. In the next video, we'll talk about other structures and nomenclature systems of carbohydrate.